Dear friends, in yesterday's lecture, we studied about the antenna parameters. Antenna parameters are the characteristics of antenna that represents regarding the performance of antenna. We have studied some 7 to 8 parameters of the antenna. We have studied radiation pattern of the antenna. We have studied the radiation resistance. We have studied the input resistance or input impedance. We have studied the efficiency of antenna. We have studied the directive gain of antenna. We have studied the bandwidth of antenna. We have studied the beam width of antenna, and we have also studied the polarization as the parameters related with the antenna in the yesterday's lectures. And we concluded that all these parameters represents regarding the performance of the antenna. Today we are going to study the types of antenna. Dear students, as we have the definition of antenna, and that is, it is a type of a structure made up of the metal object conducting metal, a group of conducting wires or simple wire made up of the copper, made up of the aluminium, which is capable to convert radio frequency signal into electromagnetic radiation, and that can be escaped in a free space. Conversely, it will intercept the electromagnetic radiation propagating through the space and convert it into its radio frequency signal back at the receiving end. That similar type of the structure, we can call it as it is the antenna, depending upon that whether it converts RF signal into the electromagnetic radiation or it converts electromagnetic radiation into radio frequency signal. There are basically two types of the antenna. One is a transmitting antenna and second one is the receiving antenna. Transmitting antenna is the antenna that is coupled to the transmitter, and obviously it converts the signal to be transmitted, that is the modulated signal, which is in the form of a radio frequency range. It is converted into the electromagnetic radiations, and these radiations are escaped in a free space for the purpose of propagation. Such an antenna we can call it as it is a transmitting antenna. Receiving antenna is an antenna which is connected to the receiver that intercepts the propagated electromagnetic radiation in the space and convert it in the radio frequency signal. We are now going to study some of the specific antennas. The first antenna we are going to study, it is known as half wave dipole antenna. So friends, we have introduced just now the types of antenna. One is a transmitting antenna. It is a structure made up of the metal which radiates the RF current, that is the radio frequency current, supplied to it as an electromagnetic energy into the space. We also studied that just now that receiving antenna is also metallic structure that intercepts the electromagnetic energy moving through space and converts into voltage and current of corresponding frequency. Now we are going to study a specific type of antenna. First antenna we are going to study, that is known as half wave dipole antenna. Friends, before 5 to 10 years back, almost all television sets which are going to act as a receiver, those are connected with the antenna which is located on the every top of the building. and that antenna contained one of the part that is known as the dipole. Dipole, which has two poles, half wave, its length is half the wavelength of the wave which is to be transmitted or which is going to be received. The metal rod, whose physical length is half the wavelength of the wave which is transmitted in a free space, that particular metal object which is going to act as the half wave dipole antenna. It is also called as the fundamental antenna, or it is also going to act as a Hertz antenna. It is also defined as it is a symmetrical antenna in which two ends are at equal potential with respect to the midpoint or a center point. This antenna, waves which are transmitted or received from this particular half-wave dipole antenna are horizontally polarized with the Earth's surface. The same half-wave dipole antenna is represented in this particular diagram. Look at here. It is a metal rod made up of the conducting material which has the two poles, one on this side, second one is on this side. As it has the two poles, it is called as a dipole. If you think about its length is half the wavelength of the wave which is going to be transmitted into the free space. It has a two poles and length is half the wavelength, so that's why it is called as half wave dipole. It may be also to be represented in this particular format also. This length of this dipole is divided into two parts and considered to be as a single aspect. That is, when you to divide exactly at the midpoint, you will get two metal rods, each of having the wavelength lambda by 4. If you place in front of each other, the entire length becomes again equal to lambda by 2. So this is also we can call as a half wave dipole. This half wave dipole represents, from the point of view of transmission of the radio frequency signal, in the form of lumped parameters. When it starts functioning of transmission, the first part it represents the inductive aspect, phenomena of the inductance. The last part that represents the phenomena of resistance. In between these two dipole, the space that is present, this act as the capacitor. Hence, it resembles with the LCR concept. So this is how the conceptual aspect related with this is with how the conceptual aspects related with the half wave dipole. Dear friends, as far as half wave dipole is considered, we can say that it is equivalent with LCR resonant circuit as just now we have described, with distributed inductance, capacitor and resistor, which are represented in the respective diagram. So, whenever the radio frequency current flows through the metallic element, the left part that represents the inductance as we have already represented. In between two lambda by 4 dipoles, the space represents the capacitor and the adjacent earth associated with RF current along with the DC resistance are. Half-wave dipole is made resonant only at one particular frequency for which it is cut. Means the designing of that particular half-wave dipole plays a very vital role. It should be cut in a proper manner so that it is made to be resonant for only one frequency, means for which the transmitter transmit that particular frequency. That frequency, resonative frequency, is determined by the L and C which are represented in the half-wave dipole. Mainly it is going to depend upon the inductance, that is the length of antenna. A resonance frequency can be changed by changing the length of antenna, because generally frequency is equal to 1 upon 2 pi root of LC. If you change the length, definitely the frequency is going to change, means resonating frequency is going to change. The quality factor Q, which is the function of outer diameter of antenna elements, which will decide tuning of antenna broadly or sharply. If diameter is more, quality factor is less, and hence bandwidth is more. If diameter is less, quality factor is more, hence the bandwidth is less. This will decide tuning of antenna for broadly aspect or for sharply aspect. When radio frequency signal containing the signal voltage is fed to the feed point of the dipole, the current starts flowing from one end to the another end, from one open end to the another open end. At open end, it becomes zero. Means at both the open end, the current becomes zero. At the center, it becomes maximum. At the cost of becoming current at both the ends zero, the related magnetic field collapses back into antenna and makes the voltage maximum at the end. What we are describing it now? When you feed the radio frequency signal, current flows from one end to the another end of half-wave dipole antenna. At both the ends, the current is zero, but at both the ends, voltage developed is maximum. As long as energy is supplied to the antenna, fixed pattern of standing wave is developed in the half-wave dipole antenna. So at the cost of this, electromagnetic radiations are going to be produced, as we have studied in the basic principle of antenna. Especially in case of lambda by 2 metal rod, standing wave pattern of voltage and current has a maximum voltage at ends and a minimum at the center. Means voltage is maximum at both the ends and minimum at the center, whereas the current is maximum at the center and minimum at both the ends. Dear friends, this is how the half-wave dipole antenna represents. If you look to that particular figure, it is represented that current is maximum at the center and it is minimum at both the ends of the rod. Current is represented by I in the figure for the lambda by 2 antenna, whereas voltage is represented as the E. If you look to that particular pattern of current and voltage, that is represented in both the diagram, that is diagram A as well as in the diagram B. maybe it is split into two aspects, or it will be treated as a single lambda by 2 antenna. Only you have to remember that current is maximum at the center and zero at both the ends. Voltage is minimum at the center and maximum at both the ends. These are the radiation patterns which are associated with half-wave dipole antenna. This particular dipole antenna has an impedance, and that's equal to 75 ohm to 73 ohm. And that's why whenever it is going to act as a transmitting or receiving antenna, the impedance of transmitting device and antenna, and also antenna and the receiving device, must be perfectly matched. If suppose we orient the antenna, means if you rotate the antenna, it doesn't affect the radiation pattern of voltage and current. The patterns are not influenced by means of an energy supply to it. The pattern is same for small or large power and small or large diameter of the elements. Means the radiation pattern doesn't depend upon energy supplied or the power applied or diameter of that particular dipole antenna. But it depends upon the length of antenna. Instead of lambda by 2, if length is made to be equal to lambda or more than that, this radiation pattern changes. For wavelength equal to lambda, maximum at the center, current is lambda, current is minimum at the center and voltage is maximum at the center. Again, if you change the length to 3 by 2 lambda, antenna current becomes maximum at the center and a minimum at both the ends. Thus, current always produces node at the free end. That is the speciality. In half-wave resonant antenna, radiation intensity is proportional to the square of the current. Try to remember this particular point. Radiation intensity is proportional to the square of the current. This current is not same everywhere. Here radiation patterns are also not same. This antenna picks the signal perpendicular to the axis of antenna. For the axis along east-west, radiation is maximum and signal picked up will be in north-south direction and vice versa. Means in general, radiation patterns of the antenna are not uniform. If you fold that particular dipole, you will get a folded dipole antenna. We already studied the dipole. Just have to fold that particular antenna so that the resulting antenna, we can call it as it is a folded dipole antenna. It has at the center feed point impedance matching is necessary because antenna impedance is 75 ohm, and if receiving impedances are not matched, then transfer of power is not so maximum, and that's why in between transmitter and transmitting antenna and also in between receiver and receiving antenna, impedance should be matched. If it is not matching, in between that some another device is being used to match the impedance respectively. Such a dipole is used as a half-wave dipole antenna in most of the cases, and that's what we are interested to study today. Friends, today we will stop here only. Rest will see it in the next